Hello everyone. In this session we will see basic Cutset incidence matrix. It is denoted by capital B. It states that the incidence of elements to basic cutsets of a connected graph is shown by basic Cutset incidence matrix. The dimensions of this matrix is represented by E cross B, where E stands for number of elements, that is transmission line, where B represents the number of basic cutsets that we are going to form for given graph. How can we find the elements inside the matrix? That can be done by using the following three conditions. The matrix element value becomes 1 if the ith element is incident to, means if any element is connected to and oriented in the same direction as the jth basic cutset. This definition I will repeat again once I explain the concept using graph. Similarly, the element becomes -1 if the ith element is incident to, that means connected to the basic cutset, and the direction is in the opposite direction. Okay, so opposite to the jth basic cutset. Bij value equal to 0 if the ith element is not incident to jth cutset. That means whatever cutset you are going to form for the given graph, if any element is not touching that basic cutset, then that element value carries 0. Then how many number of basic cutset we have to form? The number of basic cutsets usually equal to the number of tree branches. I already explained in the fundamental class how to form this graph and oriented graph. The given graph can be split into tree and co-tree. Usually the tree branches are called by the name twigs. So your number of basic cutsets must be equal to number of twigs. In a simple way, it is equal to number of tree branches. Then the direction of the basic cutset is always equal to the direction of the tree branch, because the cutsets are formed based upon the tree branches. So obviously the cutset direction will be the tree branch direction. Cutsets can have any number of links. Okay, so while forming the cutset, you can take any number of links, but one cutset must have one and only one branch. That is the condition we should follow while forming the cutset for any given graph. Once you form the B matrix can be represented as a two submatrices. One submatrix is UB, that is a U represents that unit matrix. Okay, so whatever we are going to get with respect to the branches will be the unit matrix. It is 1-to-1 correspondence. And the BL represents the Cutset matrix with respect to links. As I said, rows of UB corresponding to the branches. BL is the rows corresponding to links. And also UB shows 1-to-1 correspondence of branch and the basic cutset. Now let us see how to form the cutset for the given graph. The left hand side diagram represents original graph given, and the right hand side diagram represents after splitting the given graph into tree and co-tree. So let us split this. We know the number of tree branches must be equal to n-1. So we have a number of nodes n equal to 4. So 4 minus 1 is a 3. So we will take 3 branches to form the tree, and tree should not have any closed paths. We have taken the tree which is formed by the branches 1, 2 and 3, and the remaining lines we have considered as the links. So let us form the basic Cutset incidence matrix B. So it is formed between number of elements to number of, it's not branches, it is basic cutsets that we are forming. So number of elements, we have totally 6 elements in the graph. Now let us see how to take the basic cut set. As I said, your number of basic cut sets will be equal to the number of tree branches. So we have 3 tree branches here. We are going to take the basic cut set with respect to one branch. That means we have 3 branches. The basic cut set will be equal to 3. So, and the second condition that you should follow is, you have to cut the graph by taking one and only one branch, but you can take any number of links in that path. And one more thing, the basic cut set will divide your graph into 2 parts. That means you are cutting the graph with respect to that line. So let us see how to form the first cut set. So this is the first cut set we have cut. That means our aim is to cut with respect to branch number 1 and also to divide the graph into 2 parts. Now you can see left hand side of this line, creates one subgraph, and the right side part creates another graph. Suppose in case if you imagine that the graph is cut along the line. That's how you have to check. So now what is the direction of this cut set? So the direction of the cut set will be the same branch direction. Okay, so whichever branch you have cut, so that branch direction will be given for this cut set. So now let us see. So this is the direction. Let us consider this is cut set B1. Let us mark the element values corresponding to this cut set in this cut set B1, including the element 1, element 4 and element 6. That means these lines will carry the value 1, remaining lines will carry zeros. And in that also, some lines may be having positive, some lines may be having the negative value. Then how to check which lines will have a positive, which lines will have a negative? So if you see this direction is entering into this first node. Okay. So out of these 3 lines, whichever direction is entering into this node, that carries positive 1, opposite direction carries negative. So that means 4 and 6 are leaving the node. So these 2 elements carries -1 and 1 carries positive. Okay. So first element 1, fourth element -1, sixth element -1. Only these 3 elements are incident to this basic cut set. So those values alone will be 1. Remaining values will be zeros. Okay, that is what the definition says. These elements are represented by default Bij. I is the element number, J is the cut set. Okay. When the Bij becomes 1 means the element to be incident to this basic cut set, and the direction of this element should be same as this cut set direction. Then it carries 1. Then Bij equal to -1. So that means element is incident to the basic cut set, but the direction is away from the cut set. So then it carries -1. So these elements are not incident to this cut set. So all these 3 values will be filled by zeros. So let us mark this as a basic cut set B1. Now let us see how to form cut set with respect to the second branch. So we cannot cut in this way. If you cut in this way, 2 branches, you are cutting. So that is not allowed. And if you cut in this way, again here you are including the 1 and 2. That is also not allowed. So what we do is, we will cut in this way. Okay. So thereby you are dividing the graph also and you are satisfying the conditions also. Now let us take. So this is our second cut set, which is with respect to branch 2. And the direction of the cut set will be same as the second branch. That is downward direction. So that means this direction is entering into the node. Okay. So whichever elements involved in the cut set, that means 2, 4, 5. If all the lines direction is towards then all carries positive 1. If any element direction is in the opposite direction, then that element carries minus. So in this case, all the 3 are entering into the node. So all the 3 values will be plus 1. So 2, 4, 5 elements will carry the 1 and remaining elements 0. Now we finish the second cut set also. In the similar way, we are going to form the cut set with respect to branch 3. So this is the cut set. You are cutting only one branch and any number of links, that is, those are coming in the path. So the direction will be same as the branch direction. If you see the direction of the third branch, it is entering into the node 3. And the sixth element direction is also entering into the node 3, but fifth element is leaving. So, fifth element carries minus 1 and 3 and 6 carries plus 1 and remaining element carries 0 because those elements are not incident to basic cut set 3. So, now let us fill the values. This is how you will form the basic cut set for any given oriented graph. So now sometimes whenever we are doing the numericals, we need to consider the basic cut set matrix exclusively with respect to branches, sometimes with respect to links. So we need to partition or split this matrix accordingly. If you see in our graph, the branches are formed by using the elements 1, 2, 3 and the links are 4, 5, 6. So we are going to separate the branches and link just by drawing a straight line. Now the elements above this line are corresponding to the branches and the lines below corresponding to links. Upper matrix, you can see this is a unit matrix corresponding to branches. So you can represent this as a u suffix b, and the below matrix is the basic cut set matrix corresponding to links. So we will represent that as b suffix l. So now sometimes we need to take only the BL matrix. So that time you will just pick only the matrix corresponding to 4, 5, 6 elements, not the complete matrix. So I hope it is clear. Thank you.